We have two advanced structures with expanded octets. The first one we're going to look at here is the octahedral, 1, 2, 3, 4, 5, 6 electron domains. Assuming the central atom is attached to 6 different things, the shape would be octahedral. Notice the bond angles are 90 degrees between everything going through the central atom. And let's see, if we ended up taking off one of the bonds, one of the green ones, and putting an electron pair there, it would actually be called square pyramidal. The bond angles around these axial would still be 90 degrees, or I'm sorry, would still be 90 degrees, and also would be 90 degrees from here to here. This might squeeze them in a little bit tighter just because it's going to take up a little bit more space, but pretty much would see the 90-degree bond angles. Okay, let's say we took off another one. I'm going to do it on the other axial position, because that's what actually happens. And we had an electron pair here, an electron pair here. We'd have 4 bonded electrons, and we'd have 2 unbonded electron pairs. We'd have the square planar shape, which would have 90-degree bond angles all the way through, and that would be also derived here. So when everything's attached, it's octahedral. If one thing becomes an electron pair, it's square pyramidal. If 2 things become electron pairs, it becomes square planar, and this gives you a little visual of that. Okay, the next diagram is where I have a central atom with 5 things attached. All right, so this would be a DSP3 hybridization. And let's add something like PCl5. It would have a central atom P, and there'd be Cl's on all these spots. These green ones are typically called the equatorial, and the ones up and down are called the axial, but they would all be filled in that case. Okay, let's say I took an electron. So the bond angles here are a little bit different. They're 90 degrees going this way anytime you go through the axials. But between the equatorials, if I go from here to here to here, it's going to be 120, or here to here to here, it's going to be 120, or here to over here would be 120, going through this big jug right there. Okay, let's say I took off an electron pair like right here. Okay, I'd have 4 bonded electrons and then 1 unbonded electron pair, and this would take actually a seesaw or sawhorse shape right there. If I took off another electron pair, it would be 2 of these green ones coming off, and you'd end up with a T-shaped structure. If I took off all 3 of these equatorials and replaced those with electron pairs, I'd have 1, 2, 3 atoms in a line that would be linear. So again, trigonal pyramidal, take off 1 becomes sawhorse or seesaw. Take off 2 and put electron pairs there, becomes T-shape. Take off 3 and put electron pairs there, and it becomes a linear molecule. Hope that helps to see that visual right there.